Good morning, everyone. In this session, we shall discuss about some of the general features of the design, the parameters that will be considered for the design. As you first know that a bridge is a connecting system between a obstacle. Whenever you have an obstacle and you need to pass that obstacle, so bridge is a structure that will be provided over an obstacle to cross the passage or a river or a stream or anything for that matter, any obstacle. So when we are constructing a bridge, we need to know some of the uh, basic things, that is for the determination of waterway, that is for the determination of this waterway, what is the amount of water that is flowing in the catchment area where the bridge is coming up. We need to know that what type of stream is flowing, whether the stream is flowing with the rigid boundaries or it is quasi-alluvial rivers or it is only alluvial area. That is stream with rigid boundaries means it is having hard and inerodable bank and bed. So the banks of the river and the bed of the riverbed is non-erodable. It doesn't erode along the flow of the with the velocity of the river whenever the water is flowing. So at that velocity there won't be any erosion of the banks and the bed. That is streams with rigid boundaries. And sometimes we have quasi-alluvial soils which wherein the river, when the river is flowing in the quasi-alluvial soil, what happens is the banks will not get eroded, but the beds of the river gets eroded. So this is the nature of the quasi-alluvial rivers. Sometimes you will be having the rivers flowing in only alluvial soils. So that is called as only alluvial, which means that the banks as well as the beds are prone to get eroded. So whenever we are calculating this waterway, what is the linear waterway that we should consider? So the linear waterway that we should consider is, it is the distance actually. Waterway is the distance. So it is a distance between the abutments. That is, you have to measure perpendicular to the abutments, and it is the measured during the high flood level. So whenever the river is flowing at its full height, full full, and the bridge is at high flood level, that is the maximum level at the bridge, whatever the water that is at the ends, that is the waterway that is measured between the two edges of the flow, that is the boundaries of the water will be measured, that is perpendicular to the abutments, and this is called as linear waterway. So the area through which the water flows under a bridge superstructure is known as the waterway of the bridge, and the linear measurement of the waterway between the two edges of the flow of the water perpendicular to the abutments is called the linear waterway. So the linear waterway is the sum of the clear span. So removing all the obstacles, whatever you get the clear span, that will be the length of the waterway. So the effective linear waterway will be equal to the width of the riverbed minus obstructions to the flow. Suppose you have piers in between, so you have to minus those obstructions. If you have any rock coming in between, so that is also an obstruction to the flow of the river, that also has to be deducted to find out the effective linear waterway. So in this you can here you can see that so this is the length of the bridge, and the perpendicular direction is the bridge. The perpendicular direction is the flow, and the one that is measured perpendicular to this flow is the linear waterway. So determination of linear waterway can be done using the uh, hydrograph method or any other empirical formula method. Then comes the economic span of the bridge. So economic span means it is a span of the bridge which is determined such that the total cost of the bridge is a minimum. So economy means you are saving money. So if you determine the cost of the bridge and that is the minimum, that span whatever you are going to get, that will be the economic span of the bridge. So the span to satisfy this condition is called the economic span. The total cost of the bridge consists of the substructure and that of the superstructure. So economic span of a bridge is such that which reduces the overall cost of the bridge to a minimum. So whenever you plot a graph of span to cost, so you will be having the cost of the substructure, you will be having the cost of the superstructure. So whenever your cost of the superstructure is equal to the cost of the substructure, then that span will be most economical span. Then is a afflux. So afflux is defined as the elevation of the water level upstream of a body due to the presence of the obstruction in its flow. So whenever a river is flowing in the upstream, if there is any obstruction, then the water level rises due to the presence of this obstruction. So this rise in the water level because of the presence of some obstruction in its path, that is called as afflux. So this afflux creates some kind of energy due to fluid friction, and this can be compensated by an increase in stream potential energy in the form of afflux upstream. So whatever the local loss of energy will be there due to fluid friction, this is compensated by an increase in stream potential energy in the form of afflux upstream.